All right, so now we are going to look at how to compute things like the Euler characteristic and the genus of a two-dimensional surface, just given a polygon with some of the edges labeled. So we're going to start with this square that we saw in the last example represents the torus. And the first thing we're going to do is we're going to represent this by a word. So this can be represented by the word. And in this case, the way we're going to figure out what that word is we're going to pick one of our vertices as our starting point. And we're going to read the word either clockwise or counterclockwise. It doesn't matter as long as you're consistent. And so I generally tend to go clockwise by default. So I'm going to read the letters around clockwise, A, B, A, B. And so I'm going to write those letters, A, B, A, B. And then any of the edges whose orientations match the direction that I chose will stay as themselves, A and B. But my first B here and my second A point in the opposite direction. So those two letters with opposite orientation are going to get a little inverse symbol on them. So this is the word that represents this polygon. And eventually we're just going to start out with words and we'll construct polygons for them to help us make calculations. All right, so what we have here is a single polygon. Okay, assume this square is filled in. I'm not filling it in because it's going to make it look a little too busy for now. So we have a single polygon that has a single face, and it's represented by a single word. So one word means that we have one polygon, which tells us that we have one face. And remember, in order to compute the Euler characteristic, we need the number of faces, the number of edges, and the number of vertices. So next I notice that in my word, I have two different letters being used, A and B. So it doesn't matter that some of them have inverses and some of them don't. So I have two different letters. That tells me that I have two edges. And remember, the A edges will end up glued together to be a single edge. The B edges will end up glued together to be a single edge. So that's two total edges. So now we need to look at vertices. Well, we already saw that we end up with a single vertex, but let's see how we would figure that out if all we're given is the word to start. So I notice that this top A edge points away from point P. So I go down and find any other vertices where an edge A points away from, and I label that P. Then I notice that edge B on the left both starts and ends at point P, and so that means that both of my remaining vertices, which is where an edge B starts and ends, both have to be labeled P. So because all of my vertices of my polygon have the same label, that means I only have one vertex. So now I know that my number of faces is 1, my number of edges is 2, and my number of vertices is 1. So I can compute my Euler characteristic, vertices minus edges plus faces, which here is 1 minus 2 plus 1, which is 0. So we have an Euler characteristic of 0. The next thing that we need to know in order to compute our genus is the number of boundary components. Well, boundary components are going to come from edges that don't get glued to any other edges. They're sort of these leftover edges. And because each of our edges here are in pairs, they're all accounted for. So we have no unglued edges and therefore no boundary components. So I'm going to write that. No unglued edges means no boundary components. And I heard my child trying to open the door. Hopefully that didn't distract you too much. So no unglued edges, no boundary components. All right, now the next thing we need to know is whether this is orientable or non-orientable. Well, let's assume we don't know that this is going to be a torus. So to figure out whether it's orientable or non-orientable, we want to look at how our edges are going to be glued together, and we pay attention to the orientation. So when I glue my A edges together, because they're mirror images of each other like this, they can glue to each other without putting any twists into the surface. And similarly, when I glue my B edges together, I can glue them together. Do that the other way. I can glue them together without creating any twists in the surface. So the fact that I have no twists tells me that this surface is going to be orientable. So my formula then to determine my genus is Euler characteristic equals 2 minus 2g minus b. So we already know that our Euler characteristic is 0, and we know that our number of boundary components is 0. So 2g equals 2, or g equals 1. So what does this mean? So we have an orientable surface of genus 1 with no boundary components. So remember we said that genus of a surface is the number of handles or number of cross caps that get attached to the sphere. So if I have an orientable surface of genus 1, that means this is equivalent to a sphere with one handle and no holes. No holes. So I could kind of draw this like this if I wanted to. Woo, there's my sphere with a little handle on it. Doo -doo 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 -doo. It's kind of silly. So it's got no holes, it just has this one handle. But the better way to describe this is as a torus.